Steve Herrod led engineering at VMware as the company scaled from 30 engineers to 3,000 engineers. After 11 years, he left to become a managing director for General Catalyst, a venture capital firm. Since Steve has both operating experience and a wide view of the technology landscape as an investor, he's well equipped to discuss a topic that we have been covering on Software Engineering Daily, which is the integration of cloud and edge computing. Today, we think of the cloud as a network of large data centers operated by big players like Google, Amazon, and Microsoft. The cloud is where most of the computation across the world takes place. My smartphone and my laptop are edge devices. They are lightweight computers that don't perform much complex processing. I would not be able to run a large production database or a 3 terabyte MapReduce job on my laptop. The current division of labor makes sense in this world of smart clouds and low power, low bandwidth devices. But the devices are getting cheaper and smarter and more proliferate. Cars and drones and security cameras and sensors and other devices can serve as points of computation that are geographically between the edge devices and the cloud. With more devices between your edge device and the cloud, there's an opportunity to put computation on these devices. So instead of imagining your device simply at the edge that requests data from this super smart cloud, you can imagine a mesh of different devices geographically in between your device and the cloud. And shouldn't those devices that are between you and the cloud, shouldn't they be handling some of the computation? There's this big loss of productivity because all those devices in between you and the cloud, they're wasting compute cycles. So theoretically, they should be able to utilize those excess compute cycles to do some of the work that is required by either your device or the cloud. There's an opportunity to put computation on those devices. So everyone knows that cloud and edge computing are going to become intermingled in the coming years. We know this because it just makes economic sense. But predicting how it will play out is nearly impossible. And as an investor, if you bet on something too early, you get the same result as someone who was wrong altogether. A good analogy for how you can be too early and get something wrong that's related to this is the smart home. Everyone knows that the smart home is coming eventually, but it's very hard to tell how long it will be before smart home systems are in widespread use. So it's an open question how to invest in the space. And if you would have invested in the technology companies coming out 5 or 10 years earlier, and there were smart home companies 5 or 10 years earlier, there were smart home platforms that people did invest in, you probably lost a lot of money. So this is a pretty interesting episode, very high level. I can't wait to dive into more of this cloud and edge stuff as it comes to fruition, but we have dived into some of the stuff in past episodes that you can certainly find. I wanted to announce that summer internship applications to Software Engineering Daily are being accepted. If you're interested in working with us on the Software Engineering Daily open source project full-time, remotely this summer, send an application to internships@softwareengineeringdaily.com. We would love to hear from you. We'd love to get some fantastic interns to take this project to a new level. And if you haven't seen what we're building, check out softwaredaily.com or download the Software Engineering Daily app for iOS or Android. These have all of our episodes, all 650 episodes in a searchable format. We've got discussions, related links, lots of different material around those episodes, and it's all open source. If you want to check it out, it's at github.com/softwareengineeringdaily, and I hope you do, and I hope you ping us about it. If you are on call and you get paged at 2 a.m., are you sure you have all the data you need at your fingertips? Are you worried that you're going to be surprised by things that you missed, errors, or even security vulnerabilities because you don't have the right visibility into your application? You shouldn't be worried. You have worked hard to build an amazing modern application for your customers. You've been worrying over the details and dotting every I and crossing every T. You deserve an analytics tool that was built to those same standards. An analytics tool that will be there for you when you need it the most. Sumo Logic is a cloud-native machine data analytics service that helps you run and secure your modern application. If you are feeling the pain of managing your own log, event, and performance metrics data, check out sumologic.com/sedaily. Even if you have your tools already, it's worth checking out Sumo Logic and seeing if you can leverage your data even more effectively with real-time dashboards and monitoring and improved observability. To improve the uptime of your application and keep your day-to-day runtime more secure, check out sumologic.com/sedaily for a free 30-day trial of Sumo Logic. Find out how Sumo Logic can improve your productivity and your application observability whenever you run your applications. That's sumologic.com/sedaily. Thank you to Sumo Logic for being a sponsor of Software Engineering Daily. I'm here with Steve Herrod, the Managing Director of General Catalyst. Steve, welcome to Software Engineering Daily.
Thanks for having me.
Today, we're talking a little bit about your history, a little bit about the future. We'll start with the history. You were at VMware from 2001 to 2013, and VMware was successful because of both fundamental computer science breakthroughs, but also specific insights about how engineering organizations were working back when it got started and how they might be able to work more productively. What were the key reasons why VMware was successful?
Yeah, especially now as an investor, I realize there's always good preparation, but there's always a little bit of luck and things happening outside at the same time that work out so well. If you rewind yourself all the way back to those of you that were around in the very start of 2000 or 1999, a few things were happening. It was a time when Unix was kind of big. It was a time when there were all these different CPUs being made by people. There were MIPS processors and Alpha and these things that some of you might have heard about. Intel was not known to be like the killer company at that point. And then there was sort of the emergence of different operating systems. Certainly there was Microsoft Windows. It might have been like Windows Millennium or something at the time. But Linux was getting some headway as well. And so a lot of things happened at the same time. Intel processors were getting fast enough that you could use them to actually, they had excess capacity. And also people cared about developing for the x86 processor, for the Windows environment and for Linux. And so VMware actually started originally, it was the idea, hey, I want to try out this new Linux thing, but I don't want to have a dedicated machine for it. It'd be kind of cool if I could just run Windows and Linux on a single machine. And that's why we got a lot of developers interested, a lot of QA testing people interested. And we certainly had a long-term vision for where this would go, but that was really the origin story.
Mm-hmm. You were there as the company scaled from 30 to 3,000 people. What were the key points along that scaling where you had to change the management structure? So like I did a show recently with somebody from Box, and they were saying like you go from having an individual person who's in charge of something to a team in charge of something to an entire department in charge of something. It sounds like that was provided at least some structural schema for how they thought about scaling.
Yeah, and to be clear, that was our engineering department.
Just engineering.
Yeah,
yes,
the company itself was sort of, I think, around 14,000 people at the time I left. So I spent a lot of time actually doing this on the investor side, is trying to talk to people about what the scale will look like as you get to the next level. And if you talk to almost anyone who's been through it, will say that your job is entirely different at each order of magnitude. So when you go from 1 to 10, from 10 to 100, from 100 to 1,000, and largely it gets harder or more difficult to make things happen. And really what I keyed in on the most was how you communicate as you go through each phase. When it's just a couple people around a pizza sitting at a table, you can have high bandwidth conversations, people get it, you're interacting and course correcting all the time. Kind of each order of magnitude is almost the number of times you have to repeat saying the exact same thing through each different type of media. For things to really set in. And I would say that's the number one thing, is how do you get everyone aligned on the mission, on the priorities, on how we're going to do things. And so you would do it by meeting in person, then you'd actually, maybe at the time there weren't podcasts quite as much, but you'd do a podcast, you'd send out the email. So you had to make sure that people could absolutely understand things according to the way they like to listen to them. The other thing is you will find very, very few companies that have gone to that scale at one site. So there's a natural, as you always talk about, there's a natural challenge when you go from having everyone in one building to when you have them in multiple sites as well, which definitely hits on the notion of communication and how you get that across to them. But there's so many other things too around how you organize yourself across offices, which we could talk about. And just even how do you make sure that it's very easy we used to call it throwing grenades. When you don't really know the people at the other site, you can kind of blame them for everything and vice versa.
Oh, yeah. What about key moments in that evolution in terms of how the company was evolving? Is there anything, product developments or releases that were extremely hard to finish or get out where the organization was really strained? Things that come to mind there?
Lots of things. And I think that's really a great question to go into. You always hear about some people call it second system syndrome. I think it's third system syndrome is the one where you really get in trouble. And this is when you've shipped some kind of product, you've got some good customers, you've got things working pretty well. I typically find in companies that the second version of the product, there were so many glaring holes that you had to fix to enable the next set of sales. And these are, especially in the enterprise world, these are things like manageability or high availability, or like there's some base level of security that has to be in place. All this enterprisey stuff that is so glaringly missing from your first big product release that you just kind of have to do it. But we got into challenges, and certainly you hear of a lot of companies on the third version of a product. It's when you're feeling pretty good about yourself, and you've got an idea for all the different things you could do now that you have this core platform. We hit this problem, and is definitely a big chunk of it was my responsibility for trying to do too much in that third version of the product. And you end up just in this release hell where you're trying to get everything ready, and you've got too much confidence, so everything takes a little bit longer than you hoped, and you end up having to cut features late, and you're late on the product. So that 3.0 product for us was one of our growing up moments for me personally, but also for the whole engineering department.
Did you learn anything about decision making in that time, where because if you had to eventually cut features from the product, that probably made you maybe reflect on, we should have cut that earlier, we should have reconsidered that earlier, or just did that, and with also the knowledge, as you said earlier, that things were moving slower at that time, so there's probably more of a penalty to taking longer to make a decision because that compounded and compounded. Did it change your framework for decision making around software development? Yeah,
absolutely, and it hits for all the things that you talk about in this show quite often too. You would think that when you have more people, you can move faster and do more stuff, in the same level of productivity holds. But in actuality, as you can imagine, it's all these dependencies that you didn't have before that you weren't aware of. So as you are getting to this third version of the product, the number of dependencies that happen between systems is larger than ever. And it's sort of a classic project management where one thing can be holding up the next thing, which is holding up the next thing. And if you don't get the ordering exactly right, and you start building on a house of cards a little bit, like the fundamental core APIs you're dealing with or the core services just have to be there before you have other people piling on top of it. And so I would just say that the dependencies and making sure that the most important thing is the foundation that everyone else is building on, doing that first and making sure it's solid would have been a big deal. The other thing you have, especially when you have an ambitious set of developers, is everyone wants to ship new features and capabilities. And so there's a big morale thing around, hey, sorry, your particular feature is not going to make it. You see this a lot in the kind of companies I work with now too, is there might be some group, especially as you fragment up your department, that's responsible for something, a new file system, a new capability. But that's only part of what it means to ship the whole product. You not only have to have this capability, but it needs to be exposed through your user interface or through your APIs. And it has to go through the full realm of the QA department or system testing. And it has to be documented, by the way. Oh, and it'd be nice if marketing could actually talk about it in the product release. So what used to feel as a simple thing, I'm just going to develop this new feature, has 6, 7, 8 other groups that have to do something for it ultimately to get out into an enterprise product. And so the lesson for me was, you have to make the decision even earlier and manage the team that's unhappy about this. But it's all these other teams that are impacted that are not going to get it out the door. And in many cases, it causes more problem if you think you can make it, and then there's all these other groups that can't deliver. Oh. So you can imagine you then have the original group saying, these clowns in documentation can't get their job done and held up my cool feature. So it's really, it's as much of a people dependency and sort of morale management as it is like what is fundamentally going to keep us from getting out the door.
So when you're talking about the penalty for going too long or having to cut features late in the game on the engineering side of things, and how that can have ramifications downstream, like in marketing teams or documentation teams or sales teams. That can be really impactful, and it makes me wonder about the whole go-to-market process, because VMware was novel at the time. You had to sell the idea of virtualization. My history is not very well developed in this area, but it almost sounds kind of like what AWS has had to do, because they have had to evangelize the idea of the cloud and say, no, this is like a really good way of doing things. It's not just like a crazy thing for just startups. It's something that pretty much everybody should be doing. When you've seen AWS mature and blaze the path for the cloud, does that remind you of the evangelizing that VMware had to do?
It does on a few fronts. So VMware was started as this tool that everyone in developers and QA people really loved, and that's great. And that's a more forgiving audience for sure than when you're running your crown jewel applications in a data center on top of it. And I would say that the path that Amazon and VMware have gone through have been similar. So you can really crank things out more quickly when it's only developers and testers using it. They're getting productivity gains, and if it crashes, they restart it and life goes on. When you're trying to run, your core email or your core ERP system or whatever it would be, that's just not acceptable. It's a business critical function. So I would say in phase one, a lot of the evangelism is to developers and say, like, here's a better way to do things, and they'll take it on. But phase two ironically, is when you slow down a fair amount by having to show that you have robustness and that you've been through these certifications and that you've had your security audit, and that if you talk to the Amazon team, they've gone through exactly that, which is early adoption by develop and test, and then just a ton of work to get those mission critical applications supported. And again, part of it's technical, part of it is everything else that goes on there. We spent a ton of time early on convincing the big application developers that it was safe to run on virtualization. They wouldn't support, say, an Oracle database when run on top of VMware. And you've seen Amazon go through the same thing too, where you have to convince so many constituencies that it's okay in here.
Yeah. So AWS launched in 2006. That was about in the middle of your tenure at VMware. As AWS was becoming popular, what was the reaction inside of VMware? Did you have ideas for, hey, maybe we should be doing something similar to this, or maybe we should be leveraging it somehow? What was the VMware response to the rise of AWS?
Yeah, it'll be really fun to look at this in hindsight. I'd say there were a lot of reactions. One was to approach them and say, hey, how about you use VMware software to power your environment? And their cost model and goals were such that they wanted to use free and open source to be able to scale at the time.
They use Zen, right?
They use a very modified version of Zen, but yeah, at the time Zen was hot and everyone was interested there. But they've forked it off now, and it's a very different version. So anyway, at one point it was, hey, try to use our software. That'd be cool. And then we both have a common goal. The second phase was, this was at the time when adoption of the cloud was fairly slow, and it was, you could make whatever number it was, but most of VMware customers they were sort of poo-pooing the Amazon cloud as not safe, or like, we know best how to run a data center. We're going to use our VMware software and our cool stuff. So you get a business model where, we're doing extremely well selling to on-premises data centers and data center teams. And so it was sort of this thing on the side that we were watching out for, but doing really, really well without having a story there. And then phase three is the one where really thought we had a great solution, and part of it has worked out for sure, which was, okay, there's going to be a ton of clouds out there, public cloud services out there. There's going to be regional cloud services for each country. There might be a healthcare cloud and a federal cloud, and there was a state of Illinois cloud that we got involved with. So then our path became, hey, there's going to be a plethora of clouds out there. Let's give them all the software. And that actually worked really well. They needed some way to compete with this emerging Amazon thing, and VMware software was considered very enterprise ready. And so we had this great coalition of the willing that were doing their clouds based on our software. But at this point, it's very clear that Amazon, Google, Microsoft, the level of capital expenditure as well as technology that they've put into their own public cloud offerings are so much larger than a lot of these other ones that you just have to have a story with them in addition to these other stories.
How does that, I don't know if you can answer this, but how does that impact the strategy of the other cloud providers? If you're somebody like DigitalOcean might be a bad example, but DigitalOcean or VMware today, or Linode. There's a bunch of smaller cloud providers. What sort of strategy would you recommend?
Yeah, it's tricky. And again, on the venture capital side now, you can't meet a single startup without asking two questions. One is, what is your open source related strategy? And the other is, what is your Amazon or Google or Microsoft related strategy? Because it does permeate everything, just the sheer scale they have to build out these systems. So every one of the ones you mentioned, you can build a really great business by having some niche that you're strong at. In the case of DigitalOcean, the developers love them, and they made the simplest possible way to just get going. And they've kept their developer love, best I can tell, and really that's been a calling card. But it's very clear Amazon has them in their targets and trying to keep getting better at their own developer friendliness. I think the areas where we're going to definitely see diversity is when it's a very vertical specific public cloud offering. The rules around the financial markets or around healthcare or around retail can be such that maybe you do have these cloud services that are very well poised for providing not only a cloud that's sort of approved and certified for whatever regulations are there, but it might have value add services that are very specific to things you do in that industry. And the other thing, as everyone has sort of noted, is as we grow even more global, there's just a fair amount of data restrictions and more all the time now, such that people want to keep their data within their boundaries of some kind. And so there's pretty much every country on Earth has its own, usually a telco company providing a public cloud service. So I still think we're going to have a nice mix of clouds that are out there, many of which have their own niches that are still very good businesses. But there's still these looming behemoths on top of that are going to be ubiquitous and very heavily used.
When you're building an application, you need it to be fast, secure, and always evolving. With Kubernetes Engine on Google Cloud Platform, developers can deploy fully managed, containerized apps quickly and easily. Google has been running production workloads in containers for over 15 years. Google builds the best of what they learn into Kubernetes, which is the industry-leading open-source container orchestrator. Kubernetes Engine combines automatic scaling, updates, and reliable self-healing infrastructure with open-source flexibility to cut down development cycles and speed up time to market. To learn more about Kubernetes Engine, visit g.co/getgke. That's g.co/getgke, g.co/getgke. Thanks to Google Cloud for sponsoring Software Engineering Daily. Of the companies that you see, how many of them are multi-cloud? Do you see a lot of multi-cloud companies these days?
We do. It's something everyone talks about. I think almost every customer, I spend a lot of time with the sort of bigger CIOs of companies, and every one of them on Earth has, it's funny because we went through this at VMware as well. Every one of them has been through the process of some vendor gets super strong and then makes them feel nervous from a pricing or from even just a risk management. So this started, this was IBM in the 60s and 70s. Oracle held this mantle for a long time. The Sun became super strong in so many accounts that people were looking for a way to knock them down a little bit. VMware, absolutely. People were worried about too much going through us and too much pricing pressure. And then now on the Amazon side as well. So you always hear customers saying, I really want the option, or at least at price negotiation time, I want the chance to say I have a viable option somewhere else. And so they'll put some amount of engineering effort or business effort into keeping something alive on one of the other clouds in order to do this. So we see a lot of customers that will put their data in S3, but they'll also put it, say, in the Google Cloud. And at least with that, they can have a bit of a hedge in saying, hey, I could move over here if I need to. So I invest in a lot of companies either on the systems management side or on the security side or even on the developer side, where the calling card will be we will work across multiple clouds. It's easy to say that, and it's easy to say on multi-cloud we enable choice, et cetera. But the problem you get with almost any company is these clouds move so fast, as you were saying. The engineering velocity of new capabilities is so fast that you now have a startup trying to bring out the latest AWS service or trying to enable the cool new AI thing that is enabled. And unfortunately, you too often end up with a lowest common denominator, or at least certainly lagging behind the innovation speed of these clouds. So it's very hard to be multi-cloud and bring the most you can out of each of them. But the core concept of give me optionality or give me some kind of leverage for moving across them is alive and well.
So you're seeing people doing multi-cloud a little bit more defensively rather than... Because I've talked to some companies where like they use Google because they have access to BigQuery, for example, and it's like, oh, this is a really high leverage service and there's no equivalent on AWS. It makes me wonder how much, is that what we're going to see in the future, like more exotic, differentiated services where you actually want to have multi-cloud. You want to be ready to be able to use services like exotic services that spin up on Google or spin up on AWS, and those are like totally disjoint opportunities.
Yeah, I think it's going to be fun to watch. There's, again, these core capabilities, the amount of time that's going into like the latest, greatest machine learning or image recognition or NLP, like these services are moving at rocket speed across all of the platforms. And so I think in a short term, you'll definitely this is the better cloud to be on for the latest, greatest something. Mm-hmm. But I think we're also seeing the early stages of emerging strengths for at least the big three clouds that are out there. Mm-hmm. I think most people would say at this moment, AWS is more attractive to developers coming out the door, and they've really evangelized that well. You'd hear Microsoft is probably better at partnering with traditional enterprise companies, and they work close to your Office 365, and they have a lot of their traditional benefits. And Google, most people would say that their ability to run at scale and to do especially AI-related technologies is probably a bit ahead of everyone else. Plus, they have massive amounts of dark fiber for interesting internet connectivity. So you see these emerging moats, or at least offensive areas for each of them. But
what was the dark fiber? What does that enable?
Well, so certainly Google has invested and actually all the clouds are doing this too, but investing in their own dedicated connectivity between their own data centers so that the speed of moving data across data centers is faster than you could do over some more public network. Or, increasingly you're seeing companies that find a way to get directly locked in, a very direct network connection into these clouds from their own data centers using services from companies like Equinix or something. They're able to get really low latency, high bandwidth connectivity into parts of the public clouds. And I think that's a really offensive move to just make sure that you can move tons and tons of data into them efficiently and have a really good experience there. You couple that with just massive capital outlays. Every month you hear about the newest data center opening in a different spot. That is certainly about extra redundancy, but hey, if I have a business that has a low latency service, I'm going to choose the one closest to me because it's going to be a better customer experience. I think you're going to see these battlegrounds that are just fighting out left and right, and then some of the emerging strengths from each of them.
Yeah, so I think we're going to get into a little bit of edge-related discussion, which I think will be related to this conversation. But I want to talk a little bit about containerization, because with containerization, we saw that the deployable unit got even smaller than the VM. Although I guess with VMware, I don't know if you were thinking about these VMs as deployable units as much as like workstations maybe, but you can correct me if I'm wrong. But when you were at VMware, did it occur to you that the ways that people would be running applications could get deployed to something even smaller than a VM?
It was certainly a topic all the time. So if you go all the way to the top level, whether you're a cloud service or you're a infrastructure software service, sure, you think about number of licenses sold or how much usage there, but at the top level, you want as many applications on Earth as are possible to be running on top of your stuff. And we used to have this discussion all the time. What are today's applications? What are tomorrow's applications? And how do we make sure that they would run on top of VMware as well as possible? And so an application that runs that, like you used to have Siebel and now it's running as Salesforce in some public cloud, that's never going to run on top of your own data center software. And so that's an application that will never end up on top of some software that you have there. So you're looking at things that move to SaaS from on-premises as a set of things that move away, but you're absolutely looking at what's the next generation, like what are the cool kids building that are cloud native applications, as you would call them now, and how can we make sure that we add value when people are trying to create those applications and run them. So we watched containers were, they were sort of these user level Linux containers early on that were less glitzy and cool, but it was certainly a way that people were running software within a virtual machine. I think what the core concept, and forgetting the company, the core concept of a container that allows you to move your application and run it anywhere, we've heard that a lot. I mean, that was Java's promise, that was VMware, that's a container. It is about finding the right level of interfaces that let you spin up things and move them and share them. We had launched something at the time at VMware that's still fairly popular in infrastructure software, which was a virtual machine as the distribution package. They're called virtual appliances. And it's a way to distribute software that's fully configured, a full stack of software. And anywhere where there's this hypervisor running, you can just get it up and running it. I would just say the containers have done a great job of doing that too. I would just say they have less of the full stack in them. They're kind of counting on a common version of Linux below the covers. But it's the same concept of portability. I would just say it's lighter weight than a virtual machine, so it's sort of smaller, and you can probably run a few more of them in the same place. The core notion of portability is obviously big there. I think when you couple this lightweight containers with the other modernization of software, which is sort of the notion of microservices and decomposing a big honkin' app into a bunch of little components. Containers nicely fit with that as well. You have these things that are encapsulated talking over some network connectivity. And so I think in the particular case of containers, you hit a nice efficiency and distribution mechanism coupled with a decomposition of software that fit it fairly well. But now we're going into the next thing, which is serverless, which is yet another unit of computation that I would argue has more potential benefits than virtual machines or containers in many cases in terms of security or actual total usage and efficiency. So you're going to see these next generation encapsulation of applications, hopefully till the end of time. It's just a modernization of the software process.
What makes you say that about serverless?
I think it's fascinating. I think it's a bigger jump from VMs and containers to serverless than it was from like a VM to a container. And that's because, for me, I spent a lot of time in cybersecurity investing, for instance, and one of the biggest challenges with cybersecurity is that you have all these servers that are always on, listening on ports.
Yeah.
And they're sitting there with often old software, waiting for someone to come in and get into them. Whereas, serverless is not running unless it's running. And so at least it's not this idle, infection-ridden thing that's sort of sitting out there waiting for attack. I think that's pretty fascinating. I think the other fascinating thing, too, is because it's not taking up any cycles when it's not running, you can squeeze so many more of these functions onto a given piece of hardware. And I think that's, it's just driving the cost of computation down even further than ever. So it's really interesting to watch how that plays out. Still lots of challenges. If we thought containers weren't yet ready for mainstream, serverless is even behind that. So just a lot of the core development work to make it ready for prime time, but it feels like a very good technology.
How does it affect investing thoughts at all, or is this mostly like kind of at the edge of your periphery, just seeing Amazon and Google release serverless stuff, but how does it affect startups that you've seen?
Yeah, I'm a enterprise investor, and I do infrastructure, so I do pretty low-level stuff, and it's absolutely relevant. I spend most of my time making sure I'm aware of what the latest stuff is. However, my big focus is how do you sell to the Fortune 2000, the 5,000 companies, and my mantra, or the main thing I always look for is this has to be something that's taking you to the future. And it has to be, you want to tell a story for companies on, once you use this software, you will be better able to take advantage of this nirvana that's at the end. But it also has to have some awareness of what the world is like today.
Yeah.
And the whole reason VMware did well is it was a bridging technology from all your applications today to those same applications running in a more efficient or faster moving way. And so I would just say I always look at the startups from the concept of, great, it's an end state that people want to be in, but does it help a customer get there from this mess of stuff they have today? And that's really the difference between looking at a company that is really built for and starting with startups and like greenfield development, as we'd say, versus one that wants to go and sell into an existing enterprise.
Yeah, I actually do want to come back to security because I know that's your area, one of your areas of expertise. You have a bunch of investments in security. I've got some questions about that, but I did want to get to discussing edge computing because I've been doing some shows on this. I know you're thinking a lot about this. From your perspective, why is there an increased importance of computation at the edge?
I love the edge area right now, and it has so many interesting implications on software development that I think is funny. If you look at the history of computer science, to some extent we've had this movement to centralize and then decentralize and centralize and decentralize. And just when you think the public clouds are centralizing so much calculations and computation, you end up with all these things out in the wild that need to, at minimum, collect data and at maximum do something with the data. When you really start to think about it, you're trying to run, it might be AI models. A lot of your shows have covered kind of things you want to do at the edge. And I think you can just kind of overlay some sort of formula on how you want to think about what computation should go where. And I've been trying to actually create a mathematical formula of some kind, but there are a bunch of factors, and edge and IoT, it is so many disparate markets, you have to be really specific about which one you're after. But the traits that you tend to look at is, how far out are these edge pieces? Are they connected by a decent network or a crappy network? Are they so cheap that you can't afford to put a proper processor on them? The things you talk about a lot are, do they have to be able to respond in a real-time amount and make some decision within a certain amount of time that would preclude them from sending stuff back to some central cloud? So I think you have to really take the traits of the use case that you're doing here, and that sort of dictates what sort of hardware do you need on these edge points, what sort of network connectivity do you need, and again, what kind of processing can you do there? So I've been thinking about, almost to the same extent we talk about multi-cloud, you can think about the edge as being sort of another cloud in some cases. And the same challenge is, how do I secure something, whether it's running in a centralized public cloud or on the edge? How do I provision and update software, whether it's on one or the other? How do I do performance management? For me, it always comes back to those things around quality of service and are you actually getting the job done? And then you have to overlay that with this stuff is out in the wild, which it's hard enough for us to manage the desktop PCs that are actually on our desks in an office. How do you start managing cars that are driving all around or these sensors that are behind traffic lights? And so I think it's just a much harder problem even than the ones we've done so far.
What I would love to hear your perspective on is it too early to start thinking about this stuff? Because when I think about the places where, edge computing really matters, so we're sitting in a high-tech room, basically in a venture capital firm, and I'm looking at a phone, I'm looking at a TV, there's a video camera over here, I've got my computer, some recording devices, a lot of things that maybe they would want to have some learning capabilities. Maybe these would want to be devices at the edge, but we probably don't need them as to be edge devices anytime soon. The context that I've tried to explore are things like smart agriculture or oil refineries, where you do have a lot of devices, or shipyards where you do have a ton of devices where you actually really do want real-time updates and machine learning at the edge today. You would want that stuff today, but I don't know how. I guess that's a big market, but it's also really hard to sell to. I don't know if they're ready to buy it. I don't know if the hardware devices are ready for this stuff. So that's a mishmash of thoughts, but is it too... obviously when we get the drones flying around outside and we get the self-driving cars, and we really have high-power edge devices that we also want to be deploying machine learning models to everywhere, then it makes complete sense to think about how are you investing in this space for sure. I guess what I'm wondering about is too early today to start investing in that kind of stuff?
It's a great question. That same mishmash is in my head all the time because this is the best job on earth because we meet all the startups that are trying to do everything from the latest LiDAR-driven car decision-making to, I had an agricultural company in yesterday who was going to do weeding based on machine vision, all the way in. So I think it's pretty fascinating. I think as an investor, what we have to really look at is, will this solution be at least 10 times better than the alternative? Because there's a pain for doing all this stuff. It's new development, and again, depending on the industry, the cycles of adding new things take so long that it just has to be such a big difference to make it worthwhile. I think, again, as an investor also, you need to look at where you can put things where real spending is happening. There are a lot of existing IoT businesses that have been around for tens and 20s of years right now without being called edge devices or IoT. And whether that's telematics for fleets, to some extent these phones are all IoT, and we've had to do all sorts of pain to manage them and to keep them secure. So I would just say I personally would look at where is the impact big enough and where is there a lot of spending that you can actually get here. And that's where I would focus the startups. We see certainly a lot of we can change the world presentations, and those are awesome. But if you don't have the steps to get there, it's probably not a great investment. And that's really what we spend our time on.
So what are there specific areas where you think the timing is right today? Like if you're talking about IoT devices in a shipyard or something, are those companies willing to purchase that kind of stuff? And you can, Because I think that's like where you want to get a foothold today, is you can see that this is going to happen some point in the future, but if you put $10 million into a company today and they can't build any kind of business where they can start to get a foothold, start to experiment, start to build some kind of technology and get a little flywheel going, they're never going to stick around for long enough to get to the place where we have connected cars and drones and stuff.
Right. And I think that's a really important question. I'll answer it two ways. One is, there's the famous word platform is something you hear. I think a lot of startups have been trained to say, and we're going to become the platform for this. I don't believe there's a platform for IoT or for the edge. I think it is really going to be a number of different platforms and a number of different solutions because the needs are very different based on the domain. So I would say a couple of things, at least personally, that I don't get excited by is when someone says, we're going to build this platform and they will come and use it. I think you build a platform by having a killer use case for a specific domain, and then from there you generalize it to use elsewhere. So I'd say point one is start with the market and how you're going to fix it as opposed to a platform that could be used anywhere. That'd be step one. I do think you do have to have a vision for, okay, maybe this is my insertion point, as we call it, the first market we go after, and maybe it's not that big. But I would look for a startup to say, okay, I'm only going to start with whatever it would be, a shipyard sensor that actually has thermal controls or something. I would look for why this is the best starting point. It's a market that's hungry for it. I happen to have a proprietary relationship with someone who buys. And then I can leverage my learnings, as you said, from there to a different market. You like to see it more generally applicable than some very specific niche, but you also like to see, here's some reason I think I can be successful in a shorter amount of time. And again, that comes down to how big is the need, who do they know, what is the development cycle of whatever device that team is pitching. Those are kind of the things that we'll spend the most time in that case.
LiveRamp is one of the fastest growing companies in data connectivity in the Bay Area, and they're looking for senior level talent to join their team. LiveRamp helps the world's largest brands activate their data to improve customer interactions on any channel or device. The infrastructure is at a tremendous scale, a 500 billion node identity graph generated from over 1,000 data sources, running a 85 petabyte Hadoop cluster, and application servers that process over 20 billion HTTP requests per day. The LiveRamp team thrives on mind-bending technical challenges. LiveRamp members value entrepreneurship, humility, and constant personal growth. If this sounds like a fit for you, check out softwareengineeringdaily.com/LiveRamp. That's softwareengineeringdaily.com/LiveRamp. Thanks to LiveRamp for being a sponsor of Software Engineering Daily. Yeah, I have this friend who he did sales for a number of different IoT companies over the last decade, and he writes a lot on Quora just about his terrible experiences and doing IoT too early.
It depends where you apply it, but we see plenty of people who have developed platforms that are like, hey, we want everything to be connected, and you end up hitting a couple of problems all the time. You might be going to an appliance company and you're trying to retrofit a refrigerator or a hot tub with connectivity, and you hit a couple of problems real quickly. At least a big chunk of industries that make sense to be connected don't have software developers at the level that you might need to push this forward. The second thing you see all the time is that the cycle for creating the next appliance is 5 years. It is something that takes a long time. And so you gotta really think beyond the obvious idea of hey, this thing should be connected to who's going to do the work, what does it do to their cost model, how quick is their development cycle, and then ultimately let's say I make the killer solution for connecting dishwashers. How many connected dishwashers should there be in the world? Right. That's when reality hits a really kind of cool thing you'd like to see happen.
Are you starting to get any convincing picture of what this is going to look like? Are we going to start to see more storage devices at the edge? Or, I don't know, but what kinds of hardware developments do you think we'll see?
It's kind of fun for me. My first job before VMware was actually in a semiconductor company building low-power chips. And I do think one thing that's playing out now that we haven't seen for quite a while is sort of a reemergence of semiconductor creation and interesting new chips. You see plenty of pitches of people who are doing some aspect of the machine learning training stages all the way through deployment. So I do think we'll end up with some, either from the big players or other players, a new set of chips that are commonly used for some of the inferences and things you need to do on the edge. Whether a startup does that or whether NVIDIA continues to go forward or whether Intel gets even more involved, we'll see how that plays out. But I do think there'll be a calculation on the endpoint for folks that they want to do something with the data but can't afford to ship it all the way back. So there'll be some emergence of chip there. The data story is, again, I think you labeled the data problem exactly as we were talking about before. Some data is, there's kind of the amount of volume that's coming to this edge device, how many sensors, how many pieces of data. There's whether you want this data to be persistent or not. A lot of times it's useful data just for a minute as you bring it together or summarize it, and then you can throw it away. And then lastly, I think is how secret is the data? You don't want to be sending over clear wire a ton of data that matters. You want to probably have it encrypted on location with your device if it's truly something that needs to be persistent and that needs to be sensitive. So I think data is just going to have all these labels, and I think there'll be a deployment pattern that makes sense for each of them. Certainly, you are going to see more and more edge devices, and you'll see little systems on a chip that have some storage and they have some processing capability, and then maybe they have 5G and Bluetooth and Wi-Fi connectivity, and that'll be something that's put into a big chunk of devices. So you'll see the common stuff, and then you'll see the real, more esoteric thing for a specific use case.
Do you know much about mesh networking?
I certainly have it running in my house. That is sort of where you can do hop-to-hop networks so that you can get better coverage through them. And we are seeing that as a emerging category for home usage, as well as for how do you get these devices out in the wild to get closer and closer to a kind of...
Like, do you have any idea how good or how reliable that is? Like, if I throw a bunch of devices across my 30 square mile cornfield, and the only way they have to get data, like let's say we've got a centralized server in the farmhouse, can those devices scattered throughout the cornfield communicate data between each other and get the data to the farmhouse?
Yeah, I mean, there's basic physics involved in all this stuff, and there are a bunch of ways to get reach from a network, ranging from Project Loon, where there's like a hot air balloon collecting stuff, to just including 3G or 4G network connectivity. It's increasingly cheap just to connect a device with its own SIM card effectively, to using mesh networks, which we see in a number of cases as well. Mesh networks, just as you'd expect, the further you are, the more hops there are, the less quality the network connectivity is. So for a low data sharing environment, I think it's fine. If you need something that has maybe much more real time, low latency and connectivity, you'll see the further out, it just gets harder and harder to satisfy that. And we see a lot of, this is a little off topic, but on this notion of Internet of Things, that everyone likes to think about the consumer use cases, and they want to think about everything you do in your house from, like, we see a lot of dog connectivity solutions, like put your dog on the internet and be able to trace them. You see people trying to track water usage in their yard. But what you hit a wall really quickly, which is I don't have Wi-Fi coverage across my entire yard or wherever these things are. And so then that quickly leads into these other need for solutions like this. And there've been some good early mesh networks that have general applicability, but it remains I think there can be a lot more done on that front still.
What about security in the IoT space? I think one problem is you deploy a bunch of devices, and then some vulnerability is discovered, and then you realize, I've got all these devices, and I don't know how to update all of them with security patches, for example.
Oh my God. Have you ever tried to patch your, like you probably have at least a home modem or a router.
Oh, yeah.
It's usually like install some old version of Java on Windows XP, and an hour later, maybe we get you patched to some firmware thing you download from a web page. It's the ability to patch these things, even if you're talented, is nasty. So they haven't built that in as a first-class citizen. And I think for me,
it sounds like you've tried to do that.
Yeah, I mean, I've certainly been doing computer stuff forever, and it's a terrible. I mean, anyone can go try and do it. They're getting better, but I think for me, one of the big watershed moments was I forgot which one it was, but one of the big recent denial of service attacks was someone who had basically infiltrated a lot of the routers and other,
because of default passwords.
That's right. Default passwords is certainly one, or just it's firmware that's been, maybe it has OpenSSL in there and that's been compromised like 4 years ago, and yet you've never patched this thing. So I think the security challenges in this emerging Internet of Things world is harder than ever, partly due to out-of-date software that's hard to update, partly due to just a less controlled environment where it's out in the wild. You can imagine hacking this stuff in ways that haven't been thought about so far. I'm not an ultra-paranoid person, but I just think that is going to be an area where some pretty big solutions need to come about.
Do you have any ideas? Like, what's the dream solution that you're waiting to walk through the door that you can invest in for IoT security?
Well, it's across the board, because I do think security is it's a very broad topic, and there are a lot of different things you have to solve. I do think the notion that, I think like your Apple phone or your Google phone, the way they do updates now is pretty much best of breed. It can happen automatically overnight. It tends to not break stuff. You have to have that working everywhere. Like the notion that you need to even stop and manually do something to update is just ridiculous. So that'll be one thing that I actually think that might be a place where the government needs to put some regulations in place and say, if you're
That's
shipping...
what Bruce Schneier thinks.
Oh, good. I agree with Bruce. But I do think it's going to cause enough problems where it actually is going to mandate that companies that are maybe stodgy on how they do software just have to meet some level of compliance here, because it is a real risk. But then I think there's so many other areas of security where, like, all the data coming from these devices, however it's getting to the data center, it needs to be encrypted, and there needs to be different forms of authentication involved. And there'll be a lot of solutions for that come through. I don't think it's going to be one elixir that fixes all of it.
Yeah, so just like the basics.
Just the basics. I think folks like Amazon are doing a really good job of preaching their end-to-end sort of edge device into their cloud. Now they have a biased approach, which is everything should end up in Amazon for the most part. But I think there are going to be some really big vendors and really big software development shops that are able to think across the whole continuum of the edge all the way into the cloud.
So you got into investing in a lot of different security companies. You sit on the board of several companies that focus on different aspects of security. Was that accidental? Did you stumble into that, or have you always had an interest in computer security? No,
it was pretty intentional. When I left VMware about 5 years ago and sort of put together, if I were an investor, what areas do I think are going to be the growing areas that have the most opportunity for big changes? And cybersecurity was absolutely one of them. And it gets back to your original question too. For me, most of the time is thinking about what is this brand new world that we want to get to, and what does it look like, but how do we get there? And the number one challenge for most companies in moving to a public cloud offering is security. They're worried, right or wrong, they're worried about who's going to look at my data, can I get audited, how will I pass these different certifications, et cetera. So a lot of it I've been looking at is if we assume a world in the future where half of the company's applications are running in a public cloud and half of them might be still running in their own data centers, what does the security solution need to look like? What are the changes as containers come in and make the density so much higher? Do you have to have protection between containers on a single machine? So you kind of just go through all these different areas, and you look at a combination of where the attacks are coming from coupled with what can we now do to protect them. And that's where a lot of these investments come from. And
what is difficult about building security software or building the security software company, the sales cycle? And
here's the number one problem. If anyone goes to, like, RSA is one of the big conferences for security, there are 700 startups that you can see on the pavilion floor, and each of them are preaching some way to do something better to protect you from something that might be causing problems right now. So I actually think the largest problem, certainly there are technical issues you need to solve and to do things well and at speed. But the first problem is, how can you be so much better that you can get above the noise and you become a priority for a security department? So in that sense, it's sort of marketing, but it's also picking the right space that is sort of where the puck is going. Quick example, it used to be that we all had virus checkers on our machines, and we were most worried about downloading some rogue .exe file or something. Most of the attacks these days, about 80%, are coming through email, through attachments, and through web browsing. So you need to move the Windows-based solutions into things that are protecting the browser or that are really built into the mail subsystem, as an example. So I think you look at where things are headed and you make sure that you're in the right spot. So I think that's one. I think the other top-level challenge that I spend a lot of time on for cybersecurity is, if you look for the most in-demand job position right now, job role, it's often security. It is completely a lack of professionals that can go to all the positions that are open today. So kids out there, if you want a sure job going to cybersecurity. But what that means for a startup is that you cannot create extra work. If you're going into a company, you can't require even more time from an overworked security staff. You need to not cry wolf, which all these things tend to do, is they worry about stuff, or they raise to your attention something that might be a problem. And if you've now taken security and already overworked security teams' attention away to look at this false claim, they're not going to like you, and you've actually probably harmed things overall. So I think the other thing you look at is, in a world where there's fewer professionals? How do I fit into their current workflow? How do I only raise attention to things that are true problems? And then how do I tell people that I actually protected them? All the world is now recurring businesses of SaaS software. They don't know, you kind of want to not just protect people, but you want them to know that you actually caught some stuff because you want them to keep using your service. And so these are the things you really need to think about when you're creating a security business these days.
And there's so many different security companies out there. There's so many different providers that solve different problems. And I think a large enterprise like a big insurance company is probably going to be buying from a lot of different vendors, like multiple different vendors. And then one of those vendors, once they get into an enterprise, they might try to upsell. Like they might gain a foothold and then they try to sell other products to that same enterprise. And then you have like different vendors that are selling to the same company, and then you might have like competing vendors that are really trying to sell the same thing and they're overlapping. And just one thing I'm curious about is, this is kind of niche, but what are the dynamics of the relationships between a large enterprise and the multitude of security vendors that it might have? Are they bidding with each other? Is there some kind of what is that relationship?
It's actually a really good question. I think security is weird in the software space. There's not been that many what we call roll-ups. There's not many companies that provide this end-to-end suite of everything you could want. Certainly Symantec and folks like that try to aim that direction, but it's a business that has more, I'd say, silo products than most of the industries that we're in right now. And so you do end up, there are different parts of the organization that are buying different things. Your email team might be buying an email protection solution. Your core networking team is buying the future of firewalls. And so I would say it's not as tightly rolled up to like the chief information security officer as you might think. There's a lot of lower level people that are empowered to protect their unique environment the most they can. But zero question that as a startup, you are often competing against maybe a bigger company that says, oh, we have something kind of like that, and just buy from one vendor and you'll be fine. That's a very common move that they'll make. And so it's up to the security startup to show why their solution is not just better than this one, but 10x better to warrant having another vendor and another user interface and another training module.
So you're at General Catalyst. Do you focus on a specific stage, or is it stage agnostic?
We tend to be an earlier stage firm. We're a bit unique in that we're multinational. We're across the nation. So we have a New York, Boston, and Silicon Valley offices, and then we do primarily Series A investments. But we've done a little bit later as we see really great companies. We've gotten involved with a lot of good ones out here, from Airbnb to Stripe to a lot of the emerging ones as well. Being across multiple stages is really fun because you're solving different problems at different times in the company. Series A or even seed investment, it's like, how do you hire your first 5 people and how do you build even a alpha prototype of some piece of software? Whereas where you get to Series C and beyond, it's how do I go international? How do I build up a full sales team? How do I do strategic partnerships for reselling? So I think being multi-stage really lets you exercise different parts of the business cycle. But I think having seen early and late, you can help the other one in an interesting way.
Are there any canonical problems that you're seeing companies encounter today that maybe they didn't encounter 5 years ago, 5 or 10 years ago?
Everyone has moved. I would say 90% of companies have moved to at least having a cloud option for deploying things, and most of them have moved to a recurring revenue model for software, something people growing up these days are used to. But it's a big switch from where things used to be, where it was something that you would install on premises, and it was a license model and that sort of thing. So there's been business model evolution that affects everybody. How do I do this? To the point on security, I think recurring revenue models of subscription are fantastic, and it's really good for the customer because you have to prove your value every single month, or else they can literally turn off a switch and stop paying. So I think it's forced companies to really think about what is the direct value and how do I keep tight with the customer. Every startup has a customer success organization now, which is around, is the software actually deployed and is it being useful? And that's a real mindset change from the shelfware days of old, where you sold the software and then you really didn't care after that.
Yes. Yeah, I guess there's a little more culpability there for quality. Okay, so to close off, do you have any thoughts on where cloud computing is going that I might not hear anywhere else? Like some crazy thoughts that have just, crossed your mind that you're afraid to tell people that, how things are going to change in the next 10 or 20 years?
I think it's going to be great. I think there's a top level understanding that certainly there's these really strong cloud offerings. I think people underestimate just how big on-premises and data centers are right now and will continue to be for some class of applications. So I think I'm fairly certain that especially for larger organizations, we're going to end up with some sort of homeostasis around what types of applications and what percentages are running different places. And I do think with a lot of the toolings that we are putting in place, the ability to choose that location will get easier. There'll be less friction between moving things to a public cloud offering or moving them back or moving them between them. There's just a lot of people investing in making that better. And that ultimately, if you do have more choice, then it's going to be, certainly gives you some nice cost advantages if someone gets better. But I think it'll ultimately allow you to adapt to something unique about your application. It's certainly the case where some applications can be run in your own data center better. So I just love this idea of a world where you can more seamlessly choose where something runs based on the unique business needs that you have at any time. And again, I think the more regulated and the older an industry is, the less stuff that will be out in the crazy cloud world, and vice versa. The newer a company is with less sensitive data, they'll be 100% in the cloud.
Yeah.
And I love the idea of just watching all these balances play out across industries and company sizes.
Okay, so actually, last question. If you're like me, you're trying to figure out how to learn about cryptocurrencies, or to what degree you should be learning about them. Do you have a strategy for learning about them, or learning about their implications at least? Or is there somebody at the firm that you hired to specialize in doing that?
So there's two things. There's cryptocurrency and then there's blockchain, as I've seen you cover before too. And I think I personally am not super interested in cryptocurrency, although we have several people here trying to make sure we're well on top of what the implications are. Blockchain itself, I think, is pretty fascinating as a way to distribute technology and really apply to these distributed systems worlds in a way that is pretty interesting. So I'd like to think about all the stuff we have in IT today that is highly centralized, and could it benefit from being decentralized? To your question though, what we do all the time is try to be around the smartest people and meet as many companies and people as we can, and hopefully contribute to their own strategy and bring them together in dinners and communities. So we do a lot of dinners where we just bring together the smartest people that are hopefully helpful to each other in honing their own ideas. And that's a great way to learn.
Cool. All right. Well, Steve, thanks for coming on Software Engineering Daily. It's been great talking.
Thank you.
If you are building a product for software engineers, or you are hiring software engineers, Software Engineering Daily is accepting sponsorships for 2018. Send me an email, jeff@softwareengineeringdaily.com, if you're interested. With 23,000 people listening Monday through Friday, and the content being fairly selective for a technical listener, Software Engineering Daily is a great way to reach top engineers. And I know that the listeners of Software Engineering Daily are great engineers because I talk to them all the time. I hear from CTOs, CEOs, directors of engineering who listen to the show regularly. I also hear about many newer, hungry software engineers who are looking to level up quickly and prove themselves. And to find out more about sponsoring the show, you can send me an email, or tell your marketing director to send me an email, jeff@softwareengineeringdaily.com. And if you're a listener to the show, thank you so much for supporting it through your audienceship. That is quite enough, but if you're interested in taking your support of the show to the next level, then look at sponsoring the show through your company. So send me an email, jeff@softwareengineeringdaily.com. Thank you.
Wow.